Normally I do problems one at a time in videos, but I thought I'd group these together, so I hope it's not too long of a video for people. It's just because they were asked by someone and they're all similar topics. So what we have here is we're looking at the composite function and the domain of those composite functions. So the first one, we have f of x equals negative 5x minus 8. So this one, there are no restrictions, and the restrictions occur like when we see on the g of x with that square root, excuse me, or if you have a fraction. Those are the two common ones. But here we have a linear function, so this domain is negative infinity to infinity. But this domain here is going to be x plus 1, needs to be greater than or equal to 0. So we can subtract the 1 from both sides. So we'd have x is greater than or equal to negative 1. So the domain for this one is from negative 1 to infinity. Now, this was put together just perfect here. The student put it together. So, but the composite function would be, since it's f of g of x, we're going to have g, our g, which is this one right here, gets put inside of the f. So that gets put inside of this x, and that's what we see here. There's the g of x. And really the way you do this is you look at the intersection of what is the domain of the, what I would call the inside function and the composite function. And so that comes together to be this negative 1 to infinity. In the second case, we're looking at g of f of x. So that means we're going to have g, which is the square root of this x plus 1, but instead of x plus 1, instead of the x on the x plus 1, we put in this 5x minus 8, negative 5x minus 8, and then we have our plus 1. So while the negative 5x minus 8 had a domain of negative infinity to infinity, now we have this other situation, excuse me, where we have to look what's under the radical, and again, what's under the radical has to be greater than or equal to 0. So let me simplify this a little bit. That's going to be the square root of negative 5x minus 7. So we take that negative 5x minus 7, and we make it greater than or equal to 1, or sorry, make it greater than or equal to 0. Sorry about that. And we add 7 to both sides. So negative 5x is greater than or equal to 7. And we can divide by negative 5. And x is, now we divide it by a negative, so it switches the sign, is less than or equal to negative 7/5. So this is going to be negative infinity up to negative 7/5, and it's inclusive, so you get that bracket there. So negative infinity to negative 7/5. Excuse me. Now we go on to the next one, and the next one we're just finding f of g of x. And so that's going to be, this g function is going to go inside of the x there. F of g of x is going to be 1 over 9 over x minus 4 minus 3. So we have a couple of restrictions here. First of all, for the original g, this x minus 4 cannot be 0. And so x cannot be 4 because it makes it 0 in the denominator. Then we have the other restriction that in this new function created, this new denominator cannot be 0. So 9 over x minus 4 minus 3 cannot be 0. So it's going to be, let's see, 9 over x minus 4 cannot be 3. If I add 3 to both sides. Now multiply both sides by x minus 4 to allow me to cancel that. Let me change colors here. So this divides out. And we'll have 9 cannot equal 3x minus 12. So we can add 12 to both sides. And that's going to be what? 21 cannot equal 3x. So divide both sides by 3. X cannot be 7. So there are two values we can't have. We can't have 4 and we can't have 7. So this would be negative infinity up to 4, then union 4 to 7, then union 7 to infinity. And so I have parentheses on these because you can't include those values. That's what we're excluding. We're excluding the 4 and we're excluding the 7. Okay, let's go on to the next one then. So the next one, we're going to find g of f of x. So we're looking for, you might have to go back to blue, like you usually use blue. G of x, we know what g of x is, excuse me. G of f of x, it's going to be g of the square root of x plus 1. So, so this x plus 1 is going to go, square root of x plus 1 goes in place of this x here. So we have the square root of x plus 1 squared minus 3. And that's going to be x plus 1, because you square a square root, that gets rid of the square root, minus 3. So it's going to be x minus 2. So that's our new function, is x minus 2. And as that function sits, there's no problem. You don't need to worry about excluding any values, except we have to go back to our original inside function there, that f. And we had x plus 1 under the radical, and that needs to be greater than or equal to 0. So if we subtract 1 from both sides, x is greater than or equal to negative 1. And so that's going to be from negative 1 to infinity. It's a bracket there, negative 1 to infinity. Okay, the last problem from this set is number 15, and here we're finding f of g of x. Our g of x is this x squared minus x, and we have this radical. Excuse me. So we're looking at f of x squared minus x. That replaces this x here. That's going to be the square root of 42 minus the quantity x squared minus x. And I would, and by the way, this is f of g of x. I like to represent that. I mean, so it's negative of x squared. Negative of negative x is positive x. And then 42, so plus 42. Now, the answer they may have had, I think I talked to someone earlier today, and the answer he found out was a problem like this was they would put the constant first, then the linear term, then the variable. I don't know. I mean, this is, either way, it's the same because it's commutative. Addition is commutative. So this part is your square root of negative x squared plus x plus 42. Now the next part, this is where it gets a little more interesting than the others, is because we have this negative x squared plus x plus 42 needs to be greater than or equal to 0. And for me, I find it easier to deal with this if I multiply both sides by negative 1 to have a leading coefficient on my squared term, on my quadratic. So it's x squared minus x minus 42 is greater than or equal to 0. And so that factors to be x minus 7 times x plus 6 greater than or equal to 0. Now if I want to find those zeros, x minus 7 equals 0, so x equals 7, and x plus 6 equals 0, so x equals negative 6. Now that's not going to give us all the answers I need, and there's two ways to go about finding where this is going to work. So just remember this part right here. We want to, oh, someone's going to call me on that. I made a mistake. The sign needs to change. I multiplied by a negative number, so this is less than or equal to, less than or equal to. Okay, there we go. So one way to do this is to look at it graphically, and one way is to look at a chart. So in a graphical sense, what this is, it's a parabola that opens up, and that's the benefit of having this positive leading coefficient. And we had zeros at negative 6 and positive 7. You don't have to be real precise on this. We just know it crosses here and goes back up there. And so we're asking, where is this less than 0? Well, it's less than 0 and it's below the x-axis. and it could be equal to. That was part of the thing too. And so that means from -6 to +7 with brackets on both ends. Okay. Now, the other way to do this, and I hope I have enough space to do it. Let's see. Well, obviously I have infinite space, but I didn't know if the document would let me get down there. So this is a table approach to this, and some people like this and some don't. It's really your personal preference, what means more to you, what makes better sense to you. So if you pick a value smaller than -6, like -7, between -6 and 7, and if it's available, I pick 0. And then bigger than 7, so let's go with 8. We plug these test values in. These are test values for the different regions. And you can kind of see where it lines up, like the -7's here. So it should give me something positive. And then 0's here should give me something negative. And then 8's over here should give me something positive. So if I put the -7 here, -7 minus 7 is a -14. So I just need the sign as negative. -7 plus 6 is negative, and a negative times a negative is a positive. If I put 0 in there, 0 minus 7 is a negative. 0 plus 6 is a positive. A negative times a positive is a negative. Put the 8 in there. 8 minus 7 is a positive. 8 plus 6 is a positive. A positive times a positive is a positive. And so again, we're looking for a place where it's less than 0, so we pick this region. If we're looking for something bigger than 0, that means we're looking for something bigger than 7 and smaller than -6, and we get two regions where we do a union. But that's how we get this value. So sorry the video was a little longer than I expected. I know people like to have shorter videos, like 1 to 2 minutes. But here's the cluster of problems together. Let me know if you have questions about this. Thanks.